All right, hi kids. This is Mr. Felino for Honors Pre-Calculus. I'm going to do the flipped classroom video for 2.3 on lines. At this moment, I'm going to open up the list of things to know and list of things to do. If you have yours, you can do the same. Let's give that a second to open up. That way we can talk about what it is that we want to accomplish in this unit prior to the test, the quiz. So as we go through, we'll know what our goals and tasks are. We see here, let me zoom in a little bit here, we've got our essential questions. What are the algebraic characteristics of functions that can be applied to a wide range of mathematical equations? And what are the graphic characteristics of functions that can be applied to a wide range of mathematical equations? In pre-calculus, one big thing we have here is that this is a study of functions. The techniques we use in this chapter can be applied throughout the rest of the year. So it's really quite important that we get them straight and mastered. Things that you should know, facts, definitions, theorems that you should just be able to know and use. Definitions of slope, forms of equations for horizontal and vertical lines. Then we have our linear equations, point slope form, slope intercept form, general form. We should know the relationships for the slopes of parallel lines, the slopes of perpendicular lines, what a linear relationship is and what it's characterized by, and what a math model is. You probably know most of those already, some not. Just keep those in mind as we work through. By the end of this section, these are the skills you should have, the tasks you should be able to accomplish. They include finding the slope of a line, given a variety of information, different things. You'd be able to sketch the graphs of lines. You should be able to write equations of lines, write equations from real-world situations, interpret the meanings of the parts of a mathematical model. That means if we're given an equation from a word problem, we should be able to tell what the coefficients and the constants stand for. We should be able to do lines of best fit on our calculator and use those best fit lines in the calculator or technology to make predictions about the future or the past or something like that, and then solve applied problems. So those are the things that we want to be able to do as we work our way through that. So just going through some older things, the definition of the slope of a line is that it says let L be a line that is not parallel to the y-axis, and let point 1 have coordinates x sub 1 and y sub 1. Point 2 has coordinates x sub 2, y sub 2. Those are two different points. That's what distinct means. Distinct in the word math basically means different from each other. So they're different points. The slope can be given either by m equals the difference of the coordinates, the ratio of the difference of the coordinates, if we have the coordinates we want to calculate. If we're on the graph, we would still use rise over run. I know that it is very old, and that's where we started, but it's still valuable. And then we could use also delta y over delta x, delta, the Greek letter meaning change. And that's basically a shorthand version of this one right there. We just don't have to write it all out. If the line is parallel to the y-axis, the slope of L is undefined. And I guess at this point, we should also probably add in that. If that's true, then if L is parallel, I'm going to use the parallel symbol there, to the x-axis, then the slope is 0. Just going through a few slope things that'll be helpful to us that we've done before. So just some information there. Make sure we have that information. I expect that you can. Your teachers expect that we've already been able to find the slope of the line given 2 points and graph a line given the slope and a point on the line. If you need a little more information on that, a little more detail, that's page 120 through 122 for examples and explanations. And the only reason is that we've been working on this since Algebra 1. So at this point, we would like to make the assumption that we have the ability to complete those tasks. A few quick reminders about horizontal and vertical lines. What we want to remember about horizontal and vertical lines. If I look at my coordinate plane, and I draw, let's say, a vertical line at x equals 2. But what I know about the vertical line is that every point on that vertical line shares the same x-coordinate, and that is 2. And this might be the point 2, negative 3, and right here at the x-axis, I'll have the point 2, 0, and maybe this is the point 2, 1. And so I see that every point on that line has the same x-coordinate. So the equation of that line is simply x equals 2, because in all cases, at all times, the x-coordinate for every point on the line is 2. So it's pretty easy to remember in that particular manner. Furthermore, if I had a horizontal line, and let's say I had this horizontal line here at y equals negative 1, we can have a similar argument that every point along this line will have a y-coordinate of negative 1. Let's say negative 4, negative 1, and negative 2, negative 1, and so on and so forth. And by similar argument that we made for the x coordinates on the vertical line, we can make for the y coordinates on the horizontal line that every point on this line has a y coordinate of negative 1. Therefore, its equation is y equals negative 1. So just reminding that those vertical and horizontal lines have very simple equations of one coordinate, because there's one coordinate that is always the same for all points. So if I have to find an equation through point A with coordinates negative 3, 4 that is parallel to the x-axis, that means I'm looking at the coordinate plane. I have the point negative 3, 4. So I have that point right there. I'm going to call that point A. And I want my line to be parallel to the x-axis. Well, for my line to be parallel to the x-axis, that means it's going to be a horizontal line. All points on that horizontal line will have the same y-coordinate, and that's going to be that y-coordinate of 4. So the equation is simply y equals 4. If I take the same idea and I draw a line that is parallel to the y-axis, that means I'm going to be drawing a vertical line, and it looks like my line was a little bit off, so I'm just going to slide it over there, that every point on this vertical line has the same x-coordinate, and that x-coordinate is negative 3. So with your vertical lines and horizontal lines, it's fairly simple, and you can just work your way through like that. What we're going to do now is we're going to get into the other forms of the lines. Point slope form. An equation for the line through the point x sub 1 comma y sub 1 with a slope of m is given by y minus y sub 1 equals m times x minus x sub 1. This is real convenient, when we're given the point, any random point on the line, and the slope of that line. We don't very often end with this form, but it's a good form to start with because you do not need very specialized information. It can be any random point with the slope, and you're all set to go from there. I believe that most of us have seen that form before. Second form we're going to look at, slope-intercept form. The graph of y equals mx plus b is a line having a slope m. So m stands for the same thing it does in slope-intercept form that it did for point-slope form, and a y-intercept of b. Now, the y-intercept is still a point, but it's a very specialized point, whereas point-slope form, if I go back and look at our dual page there, I don't know if that's going to be too small on the video screen for you, but the point-slope form was a point, any random point, with the slope. Slope-intercept form is a very specific point, the y-intercept, with the slope. So the information is a little more specialized, so that form is not quite as widely used, and it's not quite so flexible in its use. The third form is general form. The graph of a linear equation is ax plus by equals c of a line, and every line is the graph of a linear equation. Now, typically it says here a, b, and c are elements of, and that's that uppercase Blackboard Z. That stands for the set of integers. So typically A, B, and C are going to be integers. You might see this in other forms in different textbooks. And when you have those different textbooks, some of them, excuse me for a moment, some of them use capital letters, AX plus BY equals C. And that is mostly, I think, for the B, because this B, that is the coefficient of the y term, is not a y-intercept like the B in the slope-intercept form. And since variables are case-sensitive, they go capital letters there. It might also be written as AX plus BY, you know, minus C equals 0, to put all the terms on the left and have a 0 on the right. I don't use that very often. Most teachers, I think, that you'll experience do not use that very often. You will most commonly see this form right here. But important things to remember, A, B, and C, the variables, the coefficients, A, B, and C, do not stand for anything of the graph. There's no slopes, there's no y-intercepts, there's no coordinates of points, no x-intercepts in this particular form. They are just typically just some numbers here. And we don't very often start with this form, but we do end with this form. And I would say that this form is most commonly used in word problems where there is no true independent variable, dependent variable. If we had to actually identify independent and dependent variables in the problems, it might be difficult to show. And they're a little more interchangeable. And you'd see this form quite often there. OK? So just reviewing some forms that we've seen before. We haven't done any problems with them yet. We just want to make sure we have that information there. Parallel lines, slopes of parallel lines. Two non-vertical lines are parallel if and only if. Remember that this phrasing, IFF, is the abbreviation for the phrase if and only if. Two non-vertical lines are parallel if and only if they have the same slope. It looks like I have a typo there. They have the same slope. The phrase if and only if, remember the phrase if and only if makes the statement reversible. Sometimes the if and only if statement is replaced with a double arrow. And that allows us to reverse the statement. This says, if I know that the two lines are parallel, then I can say that they have the same slope. Starting with the fact being parallel, I can make the assumption that the slopes are the same. But because this is an if and only if, that statement is then reversible, saying if I know they have the same slope, then I can go back and make the assumption that the lines are parallel. Many math statements are if-then. If I'm given A, then I can assume B. And that's the only direction it can go. But if and only if this, if and only if piece there allows that statement to be reversible. It basically gives you two rules within one, which is pretty nice and pretty good to have there. Slopes of perpendicular lines. Two lines with slopes of m sub 1 and m sub 2 are perpendicular if and only if, there's that if and only if again, abbreviated as IFF, if and only if their product is -1, which is simply another way of saying that their slopes are opposite reciprocals. If I were to take the equation m sub 1 times m sub 2 equals -1, and divide both sides of that equation by m sub 2, I would get the resulting equation of m sub 1 equals -1 over m sub 2, which is probably a little more familiar to you, saying that the slopes of perpendicular lines are negative reciprocals of each other. And so I have m sub 1 as my first slope. And my second slope, I got a negative out in front, and I've got the reciprocal there, 1 over m sub 2. So this is just the version of that your book uses. And it's important to note that these two versions are what we would call mathematically equivalent. So two different ways, two different representations of the statement. Two lines are perpendicular if and only if their slopes are opposite reciprocals. All right. At this moment, I'm going to stop because that's the end of the informational portion of this. From here, we would be working through some examples. You may watch the next video for the examples, and it's possible that those examples will be done in class with you. I hope I did good on my first flip, and I hope you that it jogged your memories and it gets you ready for class whenever you guys talk about this sort of stuff. Thanks.